Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. Determine the maximum displacement of the simply supported beam due to distributed loading shown in the figure. So we are given a hint here, and we'll use this, utilize symmetry, and analyze the right half of the beam only. So because of symmetry, we expect that the maximum deflection occurs at B, at the center of this beam here. And therefore, by principle, and by symmetry, the tangent at the tangent to the elastic curve at B is horizontal, therefore the slope is 0, and the maximum deflection is expected at B, at the center. So from the figure, AY equals RC, or R sub C, and therefore it is equal to 1/2 of L over 2 times WO. So AY equals R sub C equals 1/2 of L over 2 times WO. So it is equal to WOL over 4. Then the shear at B is 0 because we have WL over 2 minus this load, which is also WOL over 4 rather. So it is 0, but we have to compute for the moment at B. So moment at B is AY WOL over 4 times L over 2 minus the moment of this load, which is 1/2 L over 2 times WO, and this is 2/3 of L over 2. So simplifying, 1/8 WO L square minus WO L square over 12, and that is equal to positive WO L square over 24. So let's transmit it at B, and remember our origin is at B. So let's section this part and call that X. So this W here, intensity of the load, can be derived by similar triangles. W as to X equals WO as to L over 2. So therefore W is 2WOX over L. So let's now have the differential equation of the elastic curve with B as the origin. EIY double prime is equal to MB, which is WO L square over 24, then minus the moment of this load, 1/2 of X, W times X over 3. Substituting the value of W, so EIY double prime equals WO L square over 24 minus 1/6 W, which is 2WO X over L, X square. Simplifying further, EIY double prime equals WO L square over 24 minus WO X cube over 3L. So integrating once, EIY prime equals WO L square over 24X minus WO X to the fourth over 12L plus C sub 1 supposedly, but because the maximum deflection occurs at B, when X is 0 or at B, the tangent is horizontal, so there's no C sub 1. C sub 1 is 0. But there is C sub 2, of course. So EIY equals WOL square X square over 20 over 48, then minus WOX to the fifth over 60L plus C sub 2. So when X, let's evaluate C sub 2. When X is L over 2, at C, Y is 0. So 0 equals WO L square over 48 X square. where x is L over 2 quantity square minus WOL over 2 to the fifth over 60L plus C sub 2. So C sub 2 is WO L to the fourth over 32 times 60 minus WO L to the fourth over 48 times 4. Then solving for C sub 2. C sub 2 is negative 3 over 640 WO L to the fourth. So substitute into this equation here. So EIY equals WOL square over 48x squared minus WO x to the fifth over 60L minus 3 over 640 WOL to the fourth. So this is the equation of the elastic curve. Then we can now compute the maximum displacement when x is 0, which is at B. Then everything will be 0. Then this will be the maximum deflection. So EI delta max equals negative 3 over 640 WOL to the fourth. So delta max is negative 3 WOL to the fourth over 640 EI. So that's it. It's negative, so it is a downward deflection.